All right, this next part talks about the number e. And e is an irrational number. And if you think about it, you already know an irrational number. You know pi, but this one is very similar. This one is 2.71, well, 71, and then it goes on and on and on and on and on. Kind of like some people happen to know that pi is 3.14, and you know the decimals never end. So this is a irrational number. The decimal never ends. And basically what it's saying is the closer and closer and closer and closer, the bigger I get this number. So if I raise this formula, so the formula is actually this little part right here. So the formula is 1 over 1 n raised to the n power, okay? So the bigger this n gets, so you'll look, and they raise it to the first power, the second power, and I mean, you could type it into your calculator if you wanted, but the bigger this number, then the closer it's going to get to, this one is 2.718, and it goes on and on and on and on. This is primarily used in finance. It's used in figuring continuous interest. There's a lot of uses for E, but for the most part, just remember that it's an irrational number. And the other thing is the log and logs and exponentials are inverses of exponential functions. Okay, so it's basically if I have y equals 2 raised to the x, okay, if we make a quick little chart of that, -2, -1, 0, 1, 2. Okay, so 2 raised to the -2, 2 raised to the -2, 2 raised to the -1, 2 raised to the 0, 2 to the first, 2 squared. Okay, so really, really quick, that would be 1/4, that would be 1/2, that's 1, 2, and 4. So that's going to be something that looks, I'm trying to do this kind of quickly. That's not the greatest graph, I apologize. Okay, so the domain of this is, remember, this is going back towards negative infinity forever and ever and ever. So the domain of this one is negative infinity to positive infinity. The range is on your y-axis, so it never goes below your x-axis. So it never sinks like underground. So it's from 0, okay, because it's like at ground level, and then it goes forever and ever and ever into the sky, okay? And if you're inversing these, if you happen to know that an inverse is just a reflection over the line y equals x, I mean, I can kind of tell that this one, without doing like the math of it, its picture is going to be more like this. Because I should be able to look at these two pictures and just reflect it over the line y equals x. But a couple things about inversing. Remember, when you have an inverse, that just means that you have switched the x and y values. So I don't have to do this all over again. I could just look at the chart that I've already made and flip it. So 1/4, 1/2, 1, 2, and 4, and just know that all I need to do is reverse those. So at 1/4, I'm somewhere down around -2. At 1/2, I'm at -1. At 1, I should be at 0. So there's that. Now, also your domain and range would switch. So my range is now going to be negative infinity to positive infinity, and my domain is going to be 0 to infinity. So even these switch, okay? All right, so let's look at the next page of this. Okay, so if your logs are equivalent to their inverses of each other, Okay, all you're doing is this is your base. Okay, so this is your base. This is the exponent. And then this is the result, which a lot of times they'll use the word argument. Don't really like that, but there you go. So if it says changing between logarithmic and exponential functions, it's really pretty easy. So you're going to take this base, raise it to that power, and then this is your answer. Okay, so let's just jump in. So 9 raised to the 2, so 9 squared equals x. Okay, then this one, b to the third equals 27. So b to the third equals 27. Okay, then now they're giving it to you and they want you, we're changing back and forth between logarithmic and exponential. Okay, so my base was 5, so I know it's going to be log to the base 5. Okay, my exponent is the answer, and then the power is your argument. Okay. Now this one is a little bit more difficult. Okay, so it's asking you the third root of 64. So you're going to have to rewrite this first. So we're going to rewrite this first. Okay, so that is asking you 64 to the 1/3 power equals 4. Remember that this is our base and this is the power that you're raising it to. So it's saying 64 to the first power, but the third root. Okay, so now let's rewrite that. Okay, so log to the base of 64. And then the result, or the argument is what they like to call it. And then the last part is what was your exponent that you were raising it to. Okay, so then this one is back to what we started off with. So 7 to the third equals x. Okay, then this one is log, whatever your base number was, whatever your argument was, and then the power was y. Okay, then this one, log to the base e of 33 equals y. Okay, then this next one, log, 7 raised to the 5x, 7 raised to the 5x equals 12. Okay, and whenever you have log and e together, that actually is ln. So ln of 33 equals y.